one category of subjects having signals and systems as the fundamental subject. The signals and systems as the subject tell us about the basic definition of signals, classification of signals, operations performed on them, and then introduce systems as the means by which the operation is performed. When we talk about the system in signals and systems, the way in which we represent it everywhere is a block. Depending upon where I am using this, the impulse response h of t, if it is linear and time invariant, or input-output relation, or if I am using it as a filter, h of f or h of omega. We just give the mathematical representation of that particular system represented by a block. Maybe in a subject like control systems, if it is linear and time invariant, we may represent each block by using a transfer function h of s also. These are the representations of the system, right? Various mathematical representations of the system. But it is always a block. Based on this, we have signal processing as one subject. Communication systems as another subject. Control systems is the third subject. These are the subjects that are there in our syllabus. You should know that we talk about different modulation, demodulation processes in communication engineering as such. We talk about control systems and several representations of it. In these subjects, we represent the system as an interconnected set of blocks. And the questions also, in most of the cases, if it is a descriptive question, they will say with a neat block diagram, explain this, explain that. But what we give is, having represented the system as a single block or an interconnected system of blocks, interconnected in a specific way for a specific application. We give only the required mathematical representation of that particular system in these subjects. So, signals and systems actually is the basis for these subjects, where only the mathematical representation of the system is given. I will keep it aside now. Whenever I want to realize that mathematical function, implement that mathematical function, basically there are two options. One is purely a circuit. You know this. For every operation that we talk about, there is a corresponding circuit. Circuit is what? A set of components interconnected in a specific form, purely a circuit, or circuit plus process. Most of the cases nowadays, there is a physical circuit and there is a processor also. Some operations are done by the circuit and some of the remaining operations are performed having converted into digital form. So many complicated operations that are not so easy to implement by using a circuit are implemented in the digital form by writing a program into a processor-based system. In this, circuit will be doing its part of work. The program written into the processor will perform its part of work. Together, they deliver you the physical system that is required to do a particular operation. Now, let us come to this circuit first. In a way, processor is also a circuit for me. You know that. When I say a set of components, they are all electrical components. Interconnected in a specific form, first of all, is what? Whenever we have a set of interconnected components in a specific form, this actually is called as what? Architecture of the circuit. Again and again, maybe I'll be repeating the same example. If somebody asks you to design a simple first order RC low pass filter, immediately you will give the circuit R and C. This is the architecture of a simple low pass filter. And I know that as electronics and communication engineers, we will have the network that have so many semiconductor components, resistors, inductors, capacitors, so many components interconnected, especially in an integrated circuit, thousands of components interconnected into a huge circuit, physically when I look at it. Having given the architecture, listen carefully, we have to design the circuit. Having given the architecture, our aim is to design the circuit. Design refers to what? Fix the component values. To meet the required specification. Whenever somebody asks you to design a low pass filter, they will give you the 3 dB frequency of that particular low pass filter. Because there are two components, one frequency is what is to be achieved, F naught is equal to 1 by 2 pi RC. There are two variables, one equation, because of which there will be infinitely many solutions. Infinitely many solutions because of what? For every capacitor value that you select from the board, corresponding resistance is to be fixed. Or for every resistor that you basically pick, you have to fix that, substitute the value of the resistance and calculate the capacitance value and then put the capacitor. But whenever we want to fix the component values, even though it is many, we have to have a formula. Whenever I want to design it, this design uses design formula or formulae. Like F naught is equal to 1 by 2 pi RC. get this design formula? We will get this design formula by analyzing the circuit. Maybe in the subject network analysis, you might be wondering, why should I analyze this network? Just for the sake of analysis, we will not waste our time. Whenever I do the required analysis of that particular circuit, I will know the way in which the performance specifications of it and the component values of different components in that architecture are dependent. That is what is deriving the design formula. Given a circuit, analyzing that particular circuits required three inputs to you. What are they? KCL, current law. KVL, voltage law. And whenever I want to perform the analysis of the circuit, this analysis is, nodal analysis, mesh analysis, or general analysis of a network. I normally talk about KCL, KVL analysis, some part node, some part mesh. Whichever the procedure really takes minimum amount of time and steps, I will follow that. That's what we will do in network analysis. We need to basically use to analyze this particular circuit KCL, KVL, and VI relations, correct? Of different components. Of relation of each component. Resistor VI relation is what? Capacitor VI relation is what? Inductor VI relation is what? Diode VI relation is what? Transistor VI relation is what? That's what we have to talk about. There are so many devices with two terminals only, because of it there is only one voltage, one current. There can be multi-terminal devices, because of which there are many voltages and many currents. So whenever we want to talk about the design of a circuit with given architecture, we need to perform analysis. Analyzing any circuit requires the knowledge of KCL, KVL, and the VI relation of each component that is present in that particular network. From where they come? All these components, I am sure about it. Whether it is KCL properly, KVL properly, or the VI. I'm talking about higher level, not lower level things still. Lower level thing is what is voltage, what is current is lower level thing. There is one subject which really talks about what voltage is, what current is, in what way in a particular device voltage and current are related, and what KCL is, what KVL is. Entire information is basically derived from the subject like electromagnetics. First of all, I'll tell you, chapter wise also I will tell you. You have to accept now that whenever you are supposed to realize a system by using a circuit of given architecture, design and fix the component values, voltage, current, device VI relations of each device is given by electromagnetics as a subject. KCL, KVL also are given by electromagnetics only. KCL is continuity of current. KVL is conservative nature of the voltage potential. We will study electromagnetics from the beginning. One way to get the advantage of understanding each component, how it works, what is its VI relation. Next part. As a communication engineer, I have to send the information from one place to the other. One place to the other includes sending it from the microphone to the amplifier also. And then transmitter also. Then to a distant receiver also. Whenever we want to send information from one place to the other as communication engineers, we have to use what? Channels. What are the channels that I have? And use it in general. Number one, free space for very long distance telecommunication systems. Distant communication systems always use free space as a channel. And then whenever I talk about this free space, I have to use electromagnetic wave to carry information from transmitter to receiver through free space. Maybe in the course of time, electromagnetic wave may go through not only free space, subsurface communication, oceanic communication, submarine communications, and all. They are not free space communication systems. Wherever we basically use unbounded medium in general, as a channel, they have to use electromagnetic wave. Careful. I should first of all know the amplitude of the electromagnetic wave that is to be launched into the medium to achieve a specific range in communication engineering. Definitely, yes. Range of the communication system and the medium used determine ultimately, using them, we determine the amplitude of the electromagnetic wave to be launched into the free space so that the communication is successful. Whenever I want to fix this electromagnetic amplitude, I should know the propagation characteristics of different parts of this free space or the channel in the form of propagation constant, like phase shift constant, attenuation constant. We need to analyze it. EM wave and its propagation characteristics and propagation characteristics of different media. That I'm going to use. I should have studied my fundamental electromagnetics. Fine. I will fix depending upon the attenuation constant and the sensitivity of my receiver, I will fix the amplitude of the wave to be launched into the channel. We call it as link budget and all. Having fixed it, whatever I have in my circuit is the voltage or current representing the information. whatever I have in my circuit is voltage or current. Whatever I'm supposed to put into the channel is electromagnetic wave. 2. I need a transducer that takes voltage or current as the input and produces electromagnetic wave. What is the transducer? The transducer is antenna. Ultimately, to achieve different ranges in free space also, because of the spherical nature of the Earth, we will either go for surface wave propagation, tropospheric propagation, or ionospheric propagation. For different modes of propagation that we adopt based on the range to be achieved, I should have an electromagnetic wave launched in a specific fashion by a system that takes voltage or current as the input. That is the antenna. For different modes of propagation, the antenna is different. We need to talk about the fundamentals of an antenna. We need to know different structures of these antennas and their different propagation, the conversion of radiation characteristics, we call it, radiation patterns. Everything will come through electromagnetics. Ultimately, one more type of channel that I use is transmission line that carries information in the form of electrical variations, voltage variations, or current. Voltage variations and corresponding current variations. Please now look at it. We need to talk about this transmission line also. If I'm a proper communication engineer, if I'm a proper engineer, I don't have only one particular transmission line in my hand. There are several types of transmission lines that I keep with me. The bandwidth, one of the most important things for us. The bandwidth and the attenuation constant, as well as phase shift constant. The required values of these things are different in different applications. If it is a sensitive applications, I need to have attenuation constant to be very small. And the line should be non-distorting. Whenever we want to use a transmission line, I need to have a subject that tells me what is gamma alpha plus j beta for this. Alpha plus j beta, which is alpha is the attenuation constant, beta is the phase shift constant, comes to a given line through the basic parameters of that particular line called as R, L, G, and C. Series resistance, series inductance, shunt conductance, shunt capacitance. Oh, normally earlier they were parallel lines. Nowadays nobody uses parallel lines because we migrated from normal black and white TV to color TV, because of which we needed the quality channels. Coaxial cable. For a given coaxial cable using the material, right? A specific set of material having specific dimensions, I will basically, as I told you, from the basics of electromagnetics, I will use to say what is the resistance per unit length of that line, inductance per unit length of that line, conductance, shunt conductance per unit length, all per unit length quantities I will determine. I will also check whether it is non-distorting or not using the formula that LG is equal to RC or not. These basic parameters of a transmission line or the coaxial cable have a formula. Actually, that's what we do in the best part of electromagnetics. The medium and the dimensions, they will determine the component value. The relation between the medium used, the dimensions of it, and the component value is given by electromagnetic fields as a subject. I have to study it. Only if I can talk about RLGC of a given network, given transmission line, I will be able to derive alpha plus j beta as a function of frequency, whatever it is. Once I know alpha plus j beta for the fixed amount of power that I have, and for the range to be achieved, I will select a particular line that has specific alpha, as at least. Though not beta is a big term for us, alpha is really an important term, attenuation constant. Before reaching the receiver, it should not ultimately die down to a level where your receiver is not capable of receiving it. If the input power is at least above a particular threshold, the receiver can understand what it is. Otherwise, it not be in a position because of which I should select a particular line. I need to study transmission line characteristics. And I want to really see to it that there is no reflection. I have to talk about stub matching and all. All these things are taught properly, right, by electromagnetics as a subject to us. And we understand through electromagnetics only that as the frequency of the signal increases, in the conductor, even though it is a solid conductor, current starts taking the form of a cylinder. Thick cylinder too has increased, frequency is increased, it will become thin cylindrical current. That means with the formula for the resistance of that particular conductor, L by sigma A is the area cross section of it, L is the length of it, sigma is the conductivity of it. Throughout the area of cross section, the current will not flow because of the phenomena called as skin effect that you have to learn. Once the current starts getting confined to the surface, the effective area of cross section of the conductor carrying the current will decrease, because of which the resistance increases. At very high frequencies, because of skin effect, the current will be there only on the surface. Area of cross section tends to 0. Resistance of the conductor tends to infinity. The coaxial cable burns. It gets heated up enormously. Signal will not reach the other end. While using transmission line as the channel, bounded channel, there is a limit to the frequency up till which it can be used. And because of the fact that newer and newer technologies in communication engineering are taking higher and higher frequencies, till gigahertz they are going now. We have to go into very high frequencies, at least after modulation only we talk about. At those frequencies, if I use the transmission line even for 1 freight distance, it may not carry it till the end. Then I have to go for waveguide as the channel. Where waveguide is a hollow metallic pipe through which I will launch an electromagnetic wave that travels through the waveguide by multiple reflections. I should know how the electromagnetic wave is to be launched by putting a probe into it. And I know where to put. Analysis is required. When it is waveguide, we need to know that there is something called as TE and TM modes, not transverse electromagnetic. Earlier in free space, TEM wave. Electromagnetic wave is essentially transverse electromagnetic wave. Here, either it is transverse electric and magnetic wave is what you should know before using the waveguide. Here also, this is the bounded free space. It is not unbounded free space. We need to talk about alpha plus j beta of that. guide phase shift constant, guide attenuation constant, practicality yes. Before using it, I should know the characteristics of this waveguide to carry the signal from one end of it to the other end of it. If I want to know it, I should come through electromagnetic fields as a subject. And then the upper portion, still very high frequencies are there. Even in that case, also waveguide may become lossy. At basically called as visible frequencies, where it's basically it becomes light. Okay. The other form of the waveguide is basically will come into the picture called as optical fiber. Here it is basically light. Light is an electromagnetic wave, you know that. Ultimately, these are the things that we basically look into in GATE syllabus. That starts from Maxwell's equations. It will not talk about the devices and all. Anyway, they have removed that electrostatics and all, because anyway you have to study them. Without study, you cannot come to this level at all. If at all you want to know R, L, G, and C, you should study basic electromagnetic, basic electrostatics, basic magnetostatics, right? For inductance, time varying electric fields, time varying magnetic fields, we have to study them. Now, this is one part of the introduction. Please check it once. I'll come to the part of the introduction for the entire subject. Why each and everything is studied is what I will tell you now.